Well, the objective of this video is to show the construction of a parabola given the focus and its directrix. Suppose this point, which we label as A, be the focus of the parabola. Now then what we do is we draw its directrix, that is BC. So if we name this point as B and this point as C, that gives us the directrix. Now in order to trace the parabola whose focus is at A and directrix is at BC, let us take any arbitrary point on BC and name this point as D. Now join AD. We join AD by the segment AD. Also, we find the middle point of AD. Let's call it as point E. So we have this point E as the middle point of AD. We try to find out the right bisector of AD, that is a line which passes through E and is perpendicular to AD. So we construct this perpendicular through E, which is perpendicular to AD. Also, through D, perpendicular to BC, we construct another perpendicular, that is this. Now the two lines meet at this point, which we name as we rename it as, we name it as F. Join A to F. Now we notice that AF is equal to FD, the segment FD. Therefore, F is at the same distance from this straight line BC as it is from the focus A. Therefore, the locus of F, under the condition that D drags on the line BC, this F traces the parabola, because FA, that the distance from the focus, is equal to the distance from the directrix. Thus, we find the locus of F under the condition that D moves on the line BC. We find this red curve that gives us the parabola whose focus is at A and the directrix is the line BC. Also, if I draw a perpendicular from the point A to the line BC, that is, we construct a perpendicular line from A to BC, the point where this perpendicular from A to BC meets will be called as the vertex of the parabola. We can name it as G. That will be the vertex of the parabola. Hence we have constructed the parabola given A as its focus.